Collecting together the idea of an object into a class is really a powerful way for organizing our programs. It just makes it easier to think about a lot of things. The idea becomes even more powerful when we start working with arrays, because then we can save enormous amounts of code and typing. Things just get so much easier. Let me show you what I mean. Here's the car class we've been building up. We have some instance variables at the top, the constructor in the middle, and a bunch of methods at the bottom. I've just listed one getter and setter. There could be many more, and of course there could be many more messages. Let's shrink this down and focus just on the instance variables. Every car in our program has its own set of instance variables. So if we're drawing all these cars, this car has its own little set of 5 variables that describes where it is, what direction it's headed in, its speed, its style, and its color. Well, every other car on the screen is also carrying around its own little packet of instance variables. Every single one of them has one. So each object on the screen has its own instance variables. That's why this whole scheme works. When we send a message to a specific object, the routine gets executed with respect to the variables that describe that object. And we've seen how to create the individual objects. If this is our class, to create a new car, say a red car, we just call new, followed by the name of the constructor, which is the name of the class, and we give it all the arguments it needs. If we want to make another car, say a blue car, well, we just do it again. We call new car with a different set of arguments. And now we have 2 objects, 2 entirely separate cars, both members of the same class. If we want to move the red car, we can send it a message, go forward, and that modifies its own variables. If we want to send the blue car a message, we send it a message, like here, turn right. And again, the blue car modifies its instance variables. Red car doesn't get touched at all. And we can change those variables directly, or we can call a setter or a getter. Here, I'm telling blue car to change its speed to a value of 5. Well, this works fine if we want 2 cars, but if we want 1,000 cars, we certainly don't want to be typing all of this stuff. We want to create an array. It turns out that we make an array of objects just like we make an array of anything else. There's really no difference. So let's look at the steps involved in creating an array of objects. As always, the first thing we need to do somewhere is define the class. Then we create the array. This doesn't fill in the elements of the array yet, it just defines it. Then we fill it in, and then we can do something with the array. Say we'll draw all the cars. So let's fill in the boxes. To define the class, well, we know what that is. We saw it on an earlier slide. That's all the stuff that goes into the class car. And often we'll put that on its own tab, that is, in its own file. Now in our main program, we're going to create an array of these objects. So we create the array just like we create any other array. We name the type of the object. Here it's a car. An open and close square bracket to tell processing that this will be an array, and then the name of the array. And here I'll call it a car list. Now we need to create the memory for the array. And we do it the way we do it for every other array. We call new, followed by the name of the type of the object we need created. Here it's a car. And then between square brackets, we tell processing how many we want. So this creates an array of 15 cars. But like any array, it's not yet filled in. And so we do that by going through a loop. Typically, we do something like this. We take a variable I from 0 to the length of the array, and for each element in the array, we call the constructor. We call new car with its arguments in parentheses. That creates a new car for us, and we stick it into car list sub I. Now later we want to draw all the cars. No problem. We just run through the exact same loop again, except now car list has been filled up. So we send the message render to car list sub I. And if render took arguments, we can put them in there, and this sends the message render to that specific car. So this sends the message render to car list sub 0, and then car list sub 1, and car list sub 2, all the way through all of the cars. There's an interesting thing going on here that I'd like to point out to you so it doesn't confuse you later. we're using the word new twice on this slide in two very different ways. The use of new when we create the array is just like the use of new in every array. We're telling processing, make enough memory to store a list of this size. The new in the blue box is being used to invoke the constructor that says, I'm making a new car. So there's never any chance of getting these mixed up or confused, but I do want you to be aware that we are using the word new in two different ways. To lock things down, let's walk through the process on this slide visually. So here's our car, which is probably in its own tab, and in our main program, we create an array of cars, which I'm calling car list. When we've done this, processing has created a block of memory called car list that ultimately can hold an array of cars, but right now it doesn't have anything in it at all. So first we have to create the array. So we call new car with square brackets, telling processing, create space for 5 cars. So processing goes off and does that. It creates these empty blocks, and they're named car list sub 0, car list sub 1, and so on. Now we're ready to actually fill them in. So we go through the array, and for each one of the entries in the array, we call new car with all of its arguments. And that populates each one of these 5 cars with a new set of values. Typically, when you're creating these cars, each one will be different than the other. So here I'm not showing the mechanics for that, I'm just showing the results. Each car has its own position, direction, speed, style, and color. Now just for fun, let's change one of these values. We could use a setter if we had one, but I'll just assume that we want to reach directly into one of these cars and change a value. So let's change the style value in car list sub 1. Processing says no trouble. I know which object you're talking to. It's car list sub 1. And then you say dot style. Oh, so you're referring to the style entry in the list of variables. Now we know exactly what we're targeting, and we're going to put the value 3 in there. And now we've changed the value of style in car list sub 1. Let's try another one. This time we'll move the car. So in car list sub 4, I'll set the x coordinate of the position to 8. Again, no trouble. We just identify car list sub 4. We look at the x part of the position vector, and we change that from -4 to 8. And now we've moved the car. Working with arrays of objects can dramatically simplify our code. Let's suppose we want to make a whole bunch of cars the old way before we knew about objects. We'd have to make 5 different arrays, one for each attribute of each car. Then we'd have to actually create those 5 arrays. Then we'd have to go through the array and fill each entry in with values. Then when we wanted to actually do something with this, again, we would have to start manipulating all of these variables. This is sometimes called using parallel arrays. We're always doing the same thing to 5 arrays every time we do anything. Let's contrast this with the object approach. At the top, instead of creating 5 arrays, we just create 1 array. In the middle, instead of allocating 5 different arrays, well, we just allocate 1 array. And of course, at the bottom, instead of filling in 5 different arrays by going around a loop, we just fill in each entry in the car list with a new car. So let's contrast these side by side. In this case, we have the best of both worlds. The code is shorter and it's clearer. Let me show you an example of using an array of objects and then the power of encapsulation. Here's a variation on a program that we saw before when we talked about ATAN2. Every arrow is trying to point at the target, this yellow circle that I'm controlling with my mouse. The big arrows I imagine to be heavier, so they change more slowly than the little arrows. And I'm also color coding, so when all the arrows are pointed towards the target, they turn green, but the more that they're missing the target, the more orange they become. Here's one of the beauties of using objects. Suppose I'd like to change the behavior of this program. Maybe I don't want the big arrows to move more slowly. Instead, I want arrows that are near the target to move very fast. Let's suppose that there's like a gravity field around the yellow circle. So the arrows near the circle move very fast, but the arrows that are far away from the circle move much more slowly. Because I've implemented the arrows as objects, I only have to change the class. I don't have to change my main program that is, reading the mouse and sending messages and all of that. All I have to do is change how the class named arrow responds to the message update. And here's the result. Arrows that are near the target point move nice and quickly, and arrows that are far away move much more slowly. The size of the arrow just doesn't even matter. So I'll move down to the corner here, and you can see that in the far corner, they're orange, and now they're becoming more and more green as they catch up. And now I'll go up to the other corner, and the arrows that are far away are moving much more slowly, and they're still catching up. And as I move my way around, the arrows near my mouse are always moving much faster. They always become greener faster, and the faraway ones become orange, and it takes them time to catch up. So I've completely changed the behavior of my program, and I've completely changed how these arrows behave. By using an array, I can have any number of arrows I want, a very small number or a ridiculously large number. All I have to do is change the number in one place where I create the size of the array, and then everything else works beautifully. Just for fun, I thought, what if I replaced my arrows with pointing fingers? So I filmed my hand going from a fist to a pointing finger, and I saved the images. Now I just pick an image from that list, based on how much the hand is pointed towards the target. In this version, I've returned to the first style, where the speed of each arrow, or hand's, rotation is controlled by its size. It's a lot of fun to play with this, and you can think of lots of other ways to change the visuals. And again, this is the beauty of encapsulation. All I had to do was to change a little bit of code inside of the arrow object, and all the rest of my program runs just as it did before. Almost every time you want to make more than one instance of an object, arrays are going to be the way to go.